Now let's see the next question. If alpha and beta are the roots of x square minus 2x plus 5 equal to 0, then form the quadratic equation whose roots are given by these particular expressions. Now we are given the cubic expressions, so that means we have to somehow simplify and evaluate these expressions to get some value of them so that we can form the corresponding quadratic equation. Now to begin with, we are given that alpha and beta are the roots of the quadratic equation, so we can definitely replace x with alpha and beta and get that alpha square minus 2 alpha plus 5 equal to 0, and similarly beta square minus 2 beta plus 5 equal to 0. So now let's try to evaluate the expression which is one of the roots. Now from the first three terms, if we take alpha common, we are left with alpha square plus alpha minus 1, effect complete, plus 22. Now since we know that this particular expression is equal to 0, if we try to adjust that in the bracket, then it will definitely simplify the calculation. So therefore let us first write the required quadratic expression, that is alpha square minus 2 alpha plus 5. Now since here it is plus alpha, we must add 3 alpha to keep the original expression, and since it is minus 5, but we need, since it's minus 1 here, and since here we have written 5, so that means we must subtract 6 to adjust it, plus 22. Now here we see that this particular first portion is equal to 0, so that will vanish and we are left with 3 alpha minus 6, bracket complete, plus 22. Now further opening this bracket, we have 3 alpha square minus 6 alpha plus 22, which gives us, if we take 3 common now, alpha square minus 2 alpha plus 22. Now 3 into, now once again we see that alpha square minus 2 alpha is nothing but equal to minus 5. So therefore we can replace this particular bracket with minus 5 and plus 22. So that is nothing but 22 minus 15, which is 7. So in short, the first root in the required final equation is nothing but 7. So similarly, let's evaluate what happens to the second factor, that is, second expression is b cube plus 4 beta square minus 7 beta plus 35, which is equal to, once again taking beta common, we have beta square plus 4 beta minus 7 plus 35. So that is beta into, let's adjust the required expression first, that is beta square minus 2 beta plus 5. Now since we have 4 beta, we must add 6 beta to maintain the balance, and we must subtract 12 for the constant term. So that is equal to beta into, once again the first 3 terms vanish and we are left with 6 beta minus 12 plus 35. So taking 6 outside the bracket and taking beta inside the bracket, we have 6 beta square minus 2 beta plus 35. So once again we see that this particular portion is nothing but b square minus 2 beta, which is equal to minus 5. So we can definitely replace it with minus 5 plus 35. So therefore we have 35 minus 6 into 5 is 30. So that is nothing but equal to 5. So we see that the two roots are nothing but 7 and 5. So to form a quadratic equation is nothing but x square minus, we know the middle coefficient is nothing but minus of sum of the two roots, so which is 7 plus 5, which is 12. And lastly, the constant term is nothing but the product of roots, so that is 7 into 5 is 35 equal to 0. So therefore this is the required quadratic equation. Now here is the next question. If x is equal to 3 plus root 5, then find the value of expression x raised to 4 minus 12x cubed plus 44x square minus 48x plus 70. So here also we follow the similar approach in the previous sum, that is, somehow we have to reduce this big expression into the smaller values by having a corresponding quadratic expression. So here definitely we don't directly substitute x with 3 plus root 5 in the expression, because that would become very tedious. Now starting off with the given data, what we do here is, let's take 3 to the other side, which gives us x minus 3 equal to root 5. Now to get rid of this square root, we must square both sides. So that means we will get x square minus 6x plus 9 equal to 5. And taking the 5 on left side, we get x square minus 6x plus 4 equal to 0. Now this is another useful equation as in the previous sum, that is, we will now use this to replace in the bigger expression given to us. So that is nothing but, suppose we start off with x raised to 4 minus 12x cubed plus 44x square minus 48x plus 70, which is what we have to evaluate. Now here from the first three terms we will take x square common, so that gives us x square minus 12x plus 44 inside the bracket minus 48x plus 70. Now once again try to adjust the expression which we have already got. So that is x square minus 6x plus 4. Now since we want to finally have minus 12, we must subtract 6x here and we must add 40, so 34, and the remaining terms remain unchanged. So that gives us x square into, now the first three terms will vanish to 0, so therefore we are left with minus 6x plus 40 minus 48x plus 70. So in expanding that, we get minus 6x cubed plus 40x square minus 48x plus 70. Now here we observe that the maximum that we can take common from the first three terms here is nothing but the factor of 3, or if you want to adjust the sign, then we can take minus 3 as the biggest factor common. So if we take minus 3 and x as common, then here we are left out with 2x square and here we can take the factor of 2 as common, so it's not 3 but it is the factor of 2. So just making that correction, so it's 2x. Here therefore there will be the correction in coefficient of x square also, which is 3x square minus 20x plus 24. and plus 70. So see, now here we have got the coefficient which is other than unity for x square. So that means we must also find out what is the corresponding expression, which is nothing but if we multiply this particular equation by 3, so we will get 3x square minus 18x plus 12 equal to 0. So let us adjust this particular expression now. So that is minus 2x as it is. Here we have 3x square minus 18x, this is what we try to adjust, plus 12. Now we want minus 20, but we have written minus 18, so that means we must further subtract 2x and we must add 12 to achieve 24, and outside plus 70. So this is equal to minus 2x. Now this particular expression will become 0. So we are left out with minus 2x plus 12 plus 17. So now on expanding we get 4x square minus 24x plus 17. Now if we take 4 common from the first two terms, we will get x square minus 6x plus 17 is equal to. Now from the equation which we have found out earlier, that is x square minus 6x plus 4 equal to 0, we can definitely express x square minus 6x as nothing but minus 4. So that gives us 4 into bracket minus 4 plus 17, which is nothing but minus 16 plus 17, which is equal to 1. So that's the final answer.